Now we are going to see about an OSI reference model. The OSI reference model is a standard and have an internet. It can be developed in 1977 to 1984. The ISO released the Open System Interconnection Reference Model, that is called as an OSI reference model. It can provide the modularity to the system developers. The OSI reference model is an connection-oriented service to transfer the data from the source to destination machine. The OSI reference model can have 7 layers. They are application layer, presentation layer, sessions layer, transport layer, network layer, data link layer, and physical layer. Now we can see about each layer briefly. The first layer is an application layer. The topmost layer provides the interface that the person used to interact with the application. This is the first layer. When the user can enter the data, that the data can be moved to the first layer of this application layer. For example, Telnet, FTP, web browsers, email. Many more apps are now network aware, example in Microsoft Word. The next layer is an presentation layer. The presentation layer is responsible for defining how the information is presented to the user in the interface that they are using. That is, the presentation layer get the data in any format that can be converted to the machine understandable or an interface understandable format by this presentation layer. Example of these protocols are ASCII, BMP, GIF, JPEG, WAV, AVI and MPEG files. The next layer is a sessions layer. The sessions layer is responsible for establishing, maintaining, synchronizing and terminating the network connection. That is, we can take, for example, we can take an about a file transfer. In the file transfer, the sessions layer establishes the data connection before the data can be transmitted. They can establish the connection, and if the data can be lost, they can re-establish the connection, and it can terminate after transmitting the data. It can include a remote procedure call and a network file systems. The next layer is a transport layer. The transport layer is the fourth layer that can provide both guaranteed data delivery and not guaranteed data delivery. That is, the transport layer include a TCP and an UDP protocols. The TCP is a transport control protocols and UDP is an user datagram protocols. The TCP is an connection oriented reliable data transmission and UDP is an connectionless data transmission. So through the TCP we can establish through the TCP it can establish the connection before the data can be transmitted, and after the data completely sent to the destination they can disconnect the connection. But in an UDP, that is a user datagram protocol, they cannot establish any connection between the source and destination. They can send the data without establishing the connection from the source to the destination. So in an UDP, they can see a sequencing of the data packets so they can be reassembled at the destination. The next layer is a network layer. Network layer is a packet creation and a packet sequence controlling. That is, the network layer can get the data from the transport layer and it can convert that data into a packet creation and it can maintain the sequence controlling. It can support the services to the transport layer and a data preparation to the data link layer. The main purpose of this network layer is an route discovery and determination of the best route between the networks. That is, this layer discover the route from the source machine to the destination machine. That it can discover the path from the source to destination with the shortest distance. So it can send the data with the shortest distance. It can send the data from source to destination in a short period. The network layer provides a logical topologies and a layer 3 addresses. The routers are used in this network layer for finding the paths. The layer 3 protocol includes TCP/IP, IPX and an AppleTalk. The next layer is a data link layer. It can organize the packet data into n frames. That is, it can receive the data packets from the network layer and it can be converted into frames. The data link layer defines hardware addresses as well as the communication process that occur within the media type. The main function of the data link layer is an error correction and an retransmission. If the error is occurred when the data is transmitted from source to destination, if any occur in between the data transmission, the data link layer can correct that particular error and it can be retransmitted from the source to destination. The switches and bridges functions at the data link layer can be used. For example of the data link layer protocols are IEEE 802.2, 802.3, HDLC and an frame relay. The next layer is an physical layer. The physical layer receives the frames from the data link layer and it can be converted to an bits that is called as an zeros and ones. So physical layer can transmit the zeros and ones values. The types of signaling such as analog and digital. It can transmit the data as an analog or it can be as an digital. That is, the analog is a wave file and digital is a zeros and ones. The electrical and optical characteristics of the signals can also be used in this physical layer. Asynchronous, synchronous, simplex and off-duplex and full duplex methods can be used for the data transmission. In a simplex method, the data can be transmitted only in one direction, and in an off-duplex method, the data can be transmitted in both directions, but not at the same time. In a full duplex method, the data can be transmitted in both directions at the same time. The data rate such as 10, 100 and or gigabits can be produced by this physical layer. The topology that are used in this physical layer are star, bus or ring network. This is the first and bottommost layer is responsible for physical mechanics of the network connection, including bias and transmission of the bits. The physical layer is the bottom layer. It can receive all the data at the bottom as a zeros and ones, and the zeros and ones can be transmitted from source to destination by using these transmission media like UDP, coaxial. UDP is now is an unshielded twisted pair and coaxial cable and fiber optic. Using these transmission media, the data can be transmitted from the source to destination through this physical layer. The hubs and repeaters are used in this physical layers. So these are all the 7 layers of OSI reference model, how the data can be transmitted from the source machine to the destination machines, and each layer can functioning individually, and data can be converted from each layer, and the data can be transmitted from layer to layer through the interfaces. That data can be moved from source to destination machine. The next is another reference model is an TCP/IP reference model. The TCP/IP reference model is an connectionless data transmission. In this TCP reference model, they can have only 4 layers. The first layer is a network access layer, internet layer, host-to-host layer, process or application layer. Compared to OSI reference model, the TCP/IP reference model can have only 4 layers. The next one is data encapsulation in the layered architecture. That is how the data can be transmitted from the source machine to destination machine by the conversion of the processes. So here we can give the example. Our user data can be transmitted from the user computer. The user data can be entered here, and the data will be moved to the first layer, the topmost layer, that is an application layer, and next layer, and it can be moved to the presentation layer by the interface, and it can be converted to Unicode, and after the presentation Unicode can be moved to the next layer, systems layer, that is an security. It can provide the security to the data, and the data can be moved to the next below layer, transport layer. It can provide an TCP connection, that is an connection oriented data transmission, and it can move to the next further below layer. There is a network layer. It can provide an IP address, or it can detect the path to move the packets, and we can move the data to the below layer. It can be a data link layer to give the error frames. It can give the frames, and that particular frames can be moved to the physical layer. That physical layer can convert the frames into n bit streams, that is an zeros and ones. So after the data can move to the bottommost layer of the physical layer, the data can be transmitted from source to destination, that is to the web server, source to destination, that is a web server, by using any physical data transmission medium, that is like an twisted that can be using as a twisted pair or coaxial cable or an fiber optics. The data can be moved to the web server. So the web server is a destination machine. They can receive the data as an zeros and ones. The physical layer receives the same zeros and ones, and it can be converted to the further original data in a reverse order from the physical layer, data link layer, network layer, transport layer, systems layer, presentation layer, and to the application layer, they can receive the original data. So with this, the data can be transmitted from source to destination machine with the flow from the source machine can have an downward flow, and the source machine can have an download flow, and the destination machine can have an upload flow to receive the original data.